there we go. That's us. We're started now. Just give me a few seconds. How is that presenting the screen, Chris?
On the watch page, you mean? Yep.
Is that it on now?
Yeah, that's FPL presenting now.
Yeah, okay.
Ah, sweet.
All right, okay then, FPL. If you want to, there's there's 4 people coming in now. Yeah, so I'll just start. I'll just introduce you and how we kind of met. Right, guys, we were on I was on a hangout on the non sequitur, and the subject was gyroscopes, and yeah, that was my basic belief, and it went into what pendulous veins were and such. So my friend here, who happens, actually got first-hand experience of stripping them down, and I do believe calibrating them, and he'll explain all about gyroscopes. It's not, and it's just going to be a discussion, and I'll ask a few questions, and I'll let. And obviously, I've got Chris introducing Chris here. Chris is here as well, and I'll just FBL, if you just want to go ahead and explain. Just about why you got your channel started up, because it was quite interesting. I liked the videos that you had, so if you wanted to do that.
I run Fact-Based Living. My little alter ego on there is Newton, who's a little brain in a vat, which is kind of a shout out to Cy-10 Bruggencate and his old, you don't know you're not a brain in a vat.
Right, okay. It's quite ironic that, because, well, there's a story, but I'll tell you about that. It was just someone actually in the flat. There was an argument going on, and someone turned around. How do I know I'm not just a brain in a vat? How do you know? But anyway, carry on. Sorry there.
It's just one of those funny things, and I was like, I'm gonna take this in. This will be fun. What's kind of motivated me to start my channel is I've been involved in the skeptical movement, like the science evidence-based kind of stuff, for about a decade, sort of informally. And the one thing that I keep noticing as a trend, especially with the skeptical community, is people are very bad at communicating ideas, especially in science, without going into like PhD level like legalese, for lack of a better term.
Yeah, nicely put.
And my job right now is to literally train people who've never seen the equipment that we work on before, and to take them from 0 to 60 miles an hour in a reasonable period of time as far as learning. So I'm very good at boiling down really complicated things into something that's digestible, I think.
Yep, I'll agree there.
And so that's what I'm trying to do with my channel is it drives me nuts when somebody starts explaining like acceleration and they can't keep but using the word derivative. Like, the guy doesn't know what a derivative is. That's not how you explain acceleration. So yeah, that kind of stuff just drives me nuts. And that's not how anybody really learns anything, I don't think. So I'm going to try to make it a little bit more accessible with my channel versus, throwing around 14-syllable words.
Yeah, well, I noticed there that you started a year ago, and then you kind of stopped, and then you've kind of started again.
Yeah, so I started this, it has been just about a year. And, I sat down, I wrote out my video, I kind of laid out what I was going to do, how I was going to animate over basically an audio track. And it took me like 2.5, 3 weeks to do an episode. And I was like, this is a ridiculous schedule.
Yeah.
So I decided to, I actually took some time off. I got better at drawing. I got better at dealing with the software, and I learned some more. And then I recently came back to it because, this whole time I keep hearing like people talking like non sequitur and stuff. I'm like, oh my God, you're not explaining this correctly, and like pulling my hair out. And finally decided, nope.
I can understand that. And I'll admit, as I say, I was, I think you're totally correct there when you were saying, because I actually watched your first two, and it was quite interesting the way that when you were saying this is going to, for example, the critical thing, when you were using specific words, you explained it was in a certain context that you were using it. You said it's this, and you explained exactly how you were using the word. So like nobody had that, not room for manoeuvring, but they knew exactly how you were taking that, and then you were, even though some of the ideas that was it was a bit opposite from what I think, or maybe I was disagreeing a bit with some of the stuff, but a lot of the stuff, I had to remind myself, but you're using it in this context, So you were giving me information that was maybe, against what I thought, but I had to remember that you were actually, using the certain word or the thing that you were describing. You'd stipulated in this context, and I thought that was brilliant. That's why I clicked straight away, because there's not a lot of people, because a lot of these discussions, as you probably know, end up being talking about words and, oh, you said that, and oh, that word doesn't mean that, but it means this, and there's like a bit of confusion. So I think the way that you presented it like that, it's like a good tool to take away if people are going to go and debate. That was one of the things that I liked about your video as well.
Well, I'll definitely try to hold on to that, because that's kind of my objective, is to say, okay, this is what we're going to, talk about this week, and here's the terms as I'm using them. And then let's kind of dive into whatever the subject is, so that I don't confuse you, because it does seem, and you guys coming from kind of the other side, looking at like the skeptical community, it does seem like a lot of them kind of come off as arrogant pricks, I have to say.
Yeah, but that's prevalent in both sides, kind of thing.
Well, true.
It's like I'm kind of I look at it from both sides, because do you know what? It was like the word agnostic. When it comes to knowledge, actually, I was thinking the best way to describe me is agnostic. You know what I mean? It's like you can pick, well, when you look at it, right, you can pick and choose what information you really want to take as given, and then you can demand, right, I want to know, like, what evidence, if I'm going to believe this, what evidence have I got for it, or something like that. But I look at I kind of sit on the fence, although I do have a certain belief, but I'm still willing, if the information comes forth, I'm willing to fight against that cognitive dissonance and take in the information and admit, yep, okay, I was mistaken there. So that's why I like meeting people like yourself, and Chris as well. He's an electronics engineer, and they kind of wipe out my misconceptions. So, so.
Well, and that's why I really liked you too, because it seemed like you were asking like genuine questions versus, a lot of people on the internet, it seems like they're just there to argue. And,
gotcha questions, we call them. Gotcha questions,
Yeah, and that just drives me nuts, because it's like, if you're not actually moving anything forward and you're not helping anybody understand something, if you're just going to limit yourself to the gotcha question.
Yeah.
So, yeah, that's kind of where I'm at, and so I'm definitely going to keep trying to build the YouTube. And
I wish you luck with that. I really, I recommend, because I think on the subjects, I think, you're a good communicator, and people have got to get rid of the, it's you don't hang the guy is information, just because someone's got, it's all about the information and what the person, you know what I mean? It's not really about the person. It's about the quality information you receive. And I thought you give a really good interest, and it was quite interesting watching the videos. Anyway, I thought it was very interesting stuff. So,
well,
yes, anyway, should we get
I think
going?
that's enough introduction.
Yeah. So.
Just before we, I guess, go into stuff, hey Chris, you got any questions or anything?
Oh, hi, FBL. No, it's fine. I guess that summed it up quite nicely there. From my experience too, dealing with all sorts of people, I try to actually not sit on the fence, but listen to what people are actually saying, and try and use that to try and come to an understanding, and also try and present in a way to explain something that I'm actually seeing without any foregone conclusion as to what my beliefs are, but deal with the subject in hand. So I think that's been pretty well covered. So yeah.
Okay, cool. Well, it sounds like we're all on the same page here, so that's kind of fun.
Absolutely, yeah.
So I actually brought some stuff for show and tell.
Yeah, brilliant. Honestly, I'll say it one more time, and I'll say it more. I really appreciate the effort that you've put into getting this. You've put a lot of work into this, and
Well, I mean, it was something that I always kind of wanted. So, like every place where I've worked, I've been able to keep like one souvenir throwaway item, except for when I worked at the gyroscope place, because everything we had was, customer units that were going back out in the field. So it wasn't like I could just steal a gyro, But so I contacted my former boss and I said, hey, is there any way I could borrow or buy one? And she actually hooked me up with this gyroscope that I've got here in a mostly working fashion. So I was like, oh, sweet. And it didn't cost me hardly anything, which was super nice. And now I've got one that I can actually play with and kind of demonstrate and overhaul stuff, because part of you're going to think this is funny, but part of the reason why I took the job is because I was kind of in a similar position to you as far as understanding kind of how they worked. And I'm coming from like a round earther perspective, but still, when you go online and you try to find an explanation of how all this stuff works, the resources that are available are just crap. I mean, you can find some of the manuals and stuff and try to pour through that, but unless you have like intimate experience with how it works, then it's off. Like I did an image search at one point and was like, really, there's no explanation of how the pendulous veins or air veins work on this. That's kind of weird. So I actually, when I got a chance to work in a gyro shop, I was like, oh, that'll be kind of fun. And plus it was like a block away from my daughter's daycare at the time. So I was like, awesome. This works out sweet.
Yeah, it was destiny to bring you here. That little move.
Apparently.
Yeah. I don't know what you believe in, but but anyway, right now I've got a question, and I know the answer. I know the answer to it anyway, but I just want you to explain to people, because people, if they see this on the screen, they'll say, "Wait a minute, that's set up. That's offset, and why?" Just explain why that image we're looking at looks as if it's not level. The flight, if you want to explain what that's to do with.
Yeah, so I could actually straighten it out here. I'm going to try to move my microphone so I can manipulate stuff a little bit better.
Yeah, cool, man. Cool, yep. No problems, no worries.
Okay, so this knob here that's kind of slightly out of frame right now because I've got this zoomed in so far.
All right, we can see it. It's good.
Yeah, let's go. Let's actually back out just a hair. So this knob is for When you first start up the aircraft, if you want to cage your gyro just to kind of get it close to level and let it power up in a more level condition, you can actually pull this, and you'll see that the gyro has now better aligned itself. It's still kind of off on the roll. You'll notice that it's kind of leaning over to one side.
Yeah.
And that's probably because the balance on this is set slightly right heavy on the roll gimbal. And when we take this apart, I'll kind of show you how that works. But let's do the basics of the kind of how it works. So this knob here moves your little airplane up and down. And what that is it's a parallax adjustment, because not all pilots are the same height. And so you kind of adjust it so that the airplane is level with your horizon line across here from your point of view. And that makes it slightly more accurate, because otherwise you could be off by about as much as 5 degrees or so.
Just one thing, FPL, if I may say, these instruments are usually put into the dash of the aircraft, for want of a better word, in a vertical position. But I believe some of them you can actually put them in a certain angle, so they're easier to view as well. So by putting the offsets in, you can, even with the gyroscope at a slight angle on the display, you can still set it all horizontal and even.
Yeah, that's correct. In fact, this particular one is designed for use in a helicopter, so it has a panel tilt of about 12 degrees, and when I fire it up, you'll see what happens is if I leave it flat on the bench like this, it'll actually precess up as the gyro inside levels itself out. And that's because it's designed to be kind of tilted up like this, so that it can be below the pilot, but still provide an accurate reading. Because depending on the aircraft, some of these sit on, like, your traditional 6-pack in an airplane like a Cessna, like I fly. The 6-pack is like your car dashboard. So you've got your artificial horizon, kind of where your, the speedometer would be about, kind of off and right dead in front of you. The helicopters, they tend to have their panels with their instruments kind of down and off towards the center of the aircraft. So they actually have these tilted up so that the pilot can see them easier. And I just noticed I'm putting my hands like right in front of the camera and being...
No, that's okay. That's all right. We're getting it. We can see it. It's okay.
So I want to point out a couple of things just so you can understand like how this indicates. So there's a vertical bar here that's fixed to the chassis of the instrument, and that's what tells you your roll indication, basically. So right now it's indicating that we were in a right bank of about 5 degrees or so.
Yeah.
Because each one of those tick marks is 10 degrees to 30, and then the next one after, the next big one that's over here by this flag is 60 degrees, and then 90. And so right now this one's leaning over, and like I said, it's probably because they set the roll balance off a little bit, because when the gyro's spinning up, it actually imparts a lot of force onto your 2 gimbals, and so you kind of correct for that force by setting the balance of the gimbals slightly off in one direction until it negates that tendency to want to turn, in this case probably to the left.
Yep.
And the fun thing is, I've never actually opened up this particular model. I used to work on a very similar one, so this will be kind of interesting for me to get to open it up and see what the differences are between them.
It'll be like one of the when you see people that have got 1 million subscribers unboxing the latest camera or unboxing the latest phone or something. It's like a big, it's like, you know, that the announcement of trumpets and all that kind of stuff. But yeah, oh, this will be good. This will be cool. I'm so looking forward to this. Sorry, yeah, carry on there.
I guess they're all the same but different, right?
Yeah, I mean, they all have very similar workings inside of them. The main difference is how the erection system inside them works. The directional gyros have exactly the same gyro motor and everything inside them, but they have a kind of a different system for keeping themselves vertical than, say, the attitude indicators. So yeah, it is, and it varies from model to model and from manufacturer to manufacturer. So yeah, it just kind of depends on what the unit is, what you're going to find inside of it. Now, this is a, if I'm not mistaken, this is an AIM. I'm going to tilt this over. So there's the data plate. And yeah, it's an AIM 500, which I used to work on the 510s and 520s. So this is a little bit older than those. And I'm guessing when we get in there, we're going to find out it's got nice stamped metal veins, actual pendulous veins on it, and probably a nice machined housing. But if you look at some of the ones like RC Allen's, their parts tend to be cast parts, which when you cast metal, you end up with a lot of variation in it, and so the center of gravity on them is kind of off, so the balance is off. So they tend to need a lot more in the way of like weights and stuff to kind of keep them balanced properly, and they're kind of frustrating to work on.
Yeah, more precise, I suppose, or like a bit more fiddly to work.
Yeah, these ones are typically, they need a little bit less maintenance on them just because they're machined better and manufactured better.
Yeah.
But yeah, those old Warhorse RC Allens, man, they just won't die. Like you can keep one of those in the same aircraft for 20, 30 years, and other than having overhauls, you'll still have the same instrument.
Right.
So
yeah, they don't debate them like that anymore.
Well, and the thing that kind of sucks is now they've replaced them with solid state electronics, which work just as good, and they operate on similar principles, but the maintenance on them is a lot less. So like this particular unit would probably have to get overhauled once or twice a year, depending on how many times how much you fly. Like if you're a big air rescue operation, you're probably getting this done twice a year, and it's costing you $500-600 every time.
Yeah, exactly.
So, I understand why they're going digital, but I sure do miss my old 6-pack here. I mean, they're
you're an old school gyros or attitude indicator.
So I think what I'm going to do, if you guys don't mind, is I'm going to fire this up.
Yeah, go for it. Yes.
Now I'm going to warn you, it's going to be noisy. I'm going to try to turn my microphone so that the cardioid kind of dampens out the noise, but hopefully it's not going to drown out my voice.
What revolutions does it go up to? What revolutions are you talking?
Oh, it's really fast. I would guess several thousand a minute.
Okay.
But I honestly don't know. It's not something that I'd ever really thought to look up. Yeah. Probably I'm guessing between 5 and 10, maybe. It's pretty fast.
Yeah. Right, okay.
And while that's powering up, I'm going to scooch this back and I'll actually show you. Here's a rotor. So that's actually the motor that is spinning inside the gyroscope. And what it's got is it's got an axle at each end that threads into the housing.
Yep.
And then the outside is a very heavy weight So if I spin this, it'll keep spinning for quite a long time. The bearings in this one are kind of shot, but it still mostly works.
Yeah, yeah.
I'll see if I can, come on, stand up. Got a little live TV, right? Ah,
yeah. Well, that's what I'm saying. It's live television. You know what I mean?
there we go.
There you are. Well done.
So this at the bottom is the thing that I was showing in the video. There's some little air veins here that,
Yeah,
as the gyro spins, that's what provides the air source for the pendulous vane operation. I keep calling them pendulous vanes for some reason.
What are
they? So the pendulous vanes would be out here on the outside of the casing.
Yeah, no, what? All right, I thought there was another name for pendulous veins when you said, "Oh, I keep calling them the pendulous veins." Sorry.
Oh no, I keep using a B, so for some reason it keeps coming out as pendulous banes.
Oh, right. Never noticed.
I'm having difficulty talking to them.
It might just be the bane on your life. We never know. We'll see how this goes. Oh, sorry,
at least it's not vain.
Yeah.
But yeah, that's literally all there is to the rotor. It's got an electric motor inside, and if you look down the end, it actually has a way for the wires to come out so that the electricity can actually get into the stator part of the motor. And it's really just a standard electric motor. There's nothing more fancy to it than that. So, I accidentally kicked off my gyroscope here because the current's down to nothing. There we go. So now my gyroscope actually has power going to it. It's sort of building up in speed. Yeah, and I can hear it spooling up. It takes it about 5 minutes to get up to full speed.
Right, okay. Right.
And you'll know because you'll probably be able to hear it on my microphone when it does. It has this very distinctive high-pitched whine.
Oh, is it making a noise now? Because I can't hear
I can hear it.
Or is it? Oh, can you?
Yeah.
Yeah, I mean, it's that really high-pitched annoying whine.
A little bit.
Yeah, so I'll try to turn my cardioid away from it so that it doesn't.
It's not too bad. FPL, it's not too bad. We can still hear you. I think. I don't know. What about you, Chris?
No, it's not too bad at all. No.
Yeah.
Okay, good. Well, as long as you guys can still hear me, I mean.
Yeah.
We all got used to wearing the big over-the-ear headphones in the shop because we'd have 10 of these on Scorsby's running, and the constant whine just drove everybody nuts. So.
Yeah, I could imagine.
So it's probably got enough speed here. I'm going to go ahead and cage it. There we go. And see, now it's going to hold its position and roll pretty well. But you see how it's kind of tilting itself up?
Yeah.
And there it stopped. Yeah, that's because this one's designed to be a 12-degree panel tilt.
Yeah, I see that. I can see that. If you tilted that up, it would come into direct with the horizon. So.
Yeah, I mean, it'll.
Oh, well, excellent.
Yeah, see, it'll come right back. And if I roll it, see, you can see the roll indicators changed. And now it's come back to level because that's where I caged it.
Yeah, so actually, whatever level it's sat at when you cage it, the gyro will spin up at that, and then it'll level off if it's been calibrated with extra weights or something. And then it'll just spin up, and then that's it operational. Then, yeah.
Yeah, the cage thing is for really two functions. So if for some reason you got the aircraft into such an orientation that it caused the gyroscope to tumble, like if you went upside down or something and like really flipped the gyroscope out of whack,
Yeah,
you could stop it from tumbling by caging it. And the other main use for it is if you've just done a bunch of maneuvers and now your gyroscope is definitely way off. Like you can tell you're flying straight and level, but it's showing a 20-degree bank or something weird.
Yeah, yeah.
You could level your plane out reasonably, pull the cage, and that would speed up the leveling process basically because you're kind of caging it back to reasonably level. And then on its own, it will precess back the rest of the way to level.
Right, I've got you. It's quite a handy little tool then to have on board. Whoever thought that one up?
Yeah, and so one of the things always confuses people about that is they're like, well, so like with the attitude indicator, you might have to. You generally, during normal flight operations, don't really have to mess with it, but your directional gyro, you do. And people are like, well, why is that? And it's because they do kind of pick up a certain amount of error as you fly, especially your directional gyro. And so periodically while you fly, you're constantly tweaking your directional gyro back into alignment with your compass. And so people are like, well, then why would you use a directional gyro at all? Like, that's my first question. Because if you're constantly having to adjust it and it's not maintaining its accuracy, what's the use of it? And the use really comes in that if you have a float level in your cockpit, when you go to turn, it's going to slosh around and you may not be able to get a decent reading off of it to tell which way you're turning, to a certain precision anyway. But your directional gyro will give you an accurate reading of what heading you're rolling out on for the 5 minutes or less that you need to complete your turn. And then it's only after you re-level the plane out and you're kind of puttering along straight and level that you may have to adjust it. So it's weird. It's like it's super accurate in a turn, and then it's kind of drifting a little bit while you're flying straight. Which is counterintuitive.
I can see why it's necessary, though. Understand when you explained it there why it would be. It's just another good precaution or whatever. But I could see why they would use it.
Yeah, and that's it's those little tidbits that make all the difference, I think, in explaining stuff. Because if you didn't know that little aspect of how it operates, then of course it's going to be confusing.
Yeah. Well, that's what I'm here. That's what I'm here for. I'm here to learn. It might be boring to people listening, but this stuff fascinates me because it's.
So I'm just trying to I've got kind of a hinky power connection back here, so I was trying to get there we go, trying to get the power stabilized out.
Okay, just remind me never to ask you to wire my house for me then.
Yeah, I mean, it was so funny. We had a spare gyro lying around the shop, but we didn't have a spare power connector because they're so hard to come by.
Oh no, I appreciate what you've done here anyway in the first place. So it was,
Well, and I mean, really, I think you kind of understand how this works because you got to see it. It's you roll off a little bit while it's spinning, and the horizon stays put. So I think actually now it might be best to just open it up so you can see the inner workings.
Yeah.
Okay, well, let's just do that then. I'm just going to disconnect this.
Yeah, this is good. This is good. And
you guys get to look at the lovely back of my sink while we chat, and I disassembled this.
Chris, do you want to look at chat because I want to save my bandwidth? Do you mind? Have you got any comments? Well, FPL does that. Have you got anything to just mention or?
Sorry, buddy. What was that? The
Can you hear me?
Yeah,
I can hear you.
Yeah, I can hear you. It's
Well, if there's any questions from the chat or anything like that, if anybody's got anything, because I'm trying to save my bandwidth here because I'm not connected with the the fiber mate yet. So
Okay.
through my computer. So if there's any questions from the chat, I will say, because otherwise it might go a bit wonky. I want people to see the gyroscope.
Just looking now. There's no questions as such, but Teens just sent me a link from.
I say hello.
Yeah,
Guys.
from I've seen Jeff Whitney's channel. I was meant to say to FBL. You were saying there's hardly any information out there. Jeff Whitney has got a lot of archived footage regarding the US Air Force training videos going back to the 1960s FBL on gyros.
Yeah, I mean, I've got some of that stuff in one of my folders here as well. And yeah, there's a lot of military. It's one of those weird things you would think that there'd be less military stuff available than more. But yeah, there seems to be a lot of information from the military sources about how their gyros work, but some of their equipment works a little differently than the civilian models. And yeah, and of course the way they write military manuals isn't necessarily the most accessible version either, I don't think. So
yeah, but one of the reasons I agreed to do that when you contacted me is because I've watched a lot of videos and about it, and I thought your explanation, that video you did on the gyros over on your channel, I thought, all right, that's it was really good. And so I thought, like, what better way, because sometimes when you watch a video or read a book, you've got a question there, and now you've got to go and Google it, Google it or whatever. I'd rather talk one-to-one and get the information and get the pictures, the actual picture in my head, because I think once people get the pictures in their head, they'll be able to understand the workings or the mechanism of it, especially if you're describing everything, which I noticed you're very precise. So, like Chris is the same. He knows a lot about electrical engineering and stuff like that, and computer stuff. So he kind of goes into precise stuff, and that's the stuff I like learning. Right. This will be very interesting. I hope the chat's enjoying it. So. Oh well, but it doesn't matter. It'll stay up on my channel, so it'd be really nice. So.
Nice. So I started opening this the way I would open most AIM gyros, and of course this is one of those ones that's just slightly different. So now I realize I got to take the front off, I think.
Oh well, even if I was going to say, that I mean. Yeah, if it's too much effort or whatever, if you, because I thought that CAD drawing you did as well was I was impressed with that. That kind of cleared up, just watching that thing, that cleared up and gave me a very deep, a lot deeper understanding of actually how it worked, and then your video as well. So it was, as I say, if it's too much effort to open it up, but. I would like to see inside one. I still would like to see inside it.
I promised you to see the inside. It's not a lot of effort. It's just a matter of figuring out which screws to take out of where. And actually, I kind of want to see this one, what exactly it's got in it, because like I said, this is one of the ones that I didn't get a chance to work on because it's a less common gyro.
I usually,
because I gotta let the gyro spin down anyway before I can get to too much.
Oh yeah, of course. Oh, does it take it time spinning down? Does it?
Yeah, it takes it. Yeah, because they have pretty good bearings in them, so usually it takes them 5 minutes or so at least to spin down.
Right. Okay. All right.
Nice picture of a champagne cork there.
Yeah, what you been on the champagne or something?
That was actually from when me and my wife got married. So.
Oh, congratulations, my friend.
So yeah, we kind of saved the cork. So.
Oh, good stuff. No.
So yeah,
in Denmark at New Year, you'll save the champagne cork and then put a a coin in it, a silver coin in it, so, and save it. But,
yeah, so I managed to get the back cover off of there, and then I was like, oh, it's got an extra hidden little bulkhead in this one, so I just got to take the front off. There we go. The hard part with these is always getting that stupid pull to cage knob off, because they tend to get kind of welded in place. Oh, and of course, this is one that's got 2 screws that hold it in. So,
of course,
gotta love engineers.
Easy now, my friend's one.
It always cracks me up with mechanical engineers, because they. I had a friend of mine that was he was actually an instructor in mechanical engineering, and he used to harp in his students that there's very few jobs you can't do with 4 bolts and 4 screws. Because he constantly would get these like graduation project things, and they would have like these just crazy number of screws and stuff on them, and it was like, no, you don't need to be that complicated. Be nice and easy. And 4 bolts, 4 screws, 4 nuts, done.
And washers.
Oh yeah, washers are helpful.
Yeah, but it's quite the message that he was given was, it was a simple message. It was deep though. It was like, like what you say, just make it simple, man. That's the thing that'll win. It's all about, if you're an engineer or a structural engineer, it's all about the structure and understanding, the stress points and foundation, where all the, the weight of an object goes to, cantilevers and everything, and sometimes, they could do a cantilever's the simplest form, and that would be 4 bolts and 4 screws, to demonstrate that. So.
See, and I'm running into that problem in disassembling this here, because there's like 12 screws on the front of this faceplate, and I'm trying to figure out which 4 of the 12 actually take the faceplate off. And of course, it's the last set that I got to.
Obviously. Oh, man.
Yeah, because I've just taken out 8 screws, and now it's still stuck. So it has to be this last set.
Excuse me, JBL, but this is rather unprofessional. Myself and Chris usually have, we're quite on the ball.
Yeah, I mean, I thought about disassembling this before, and then I thought, well, yeah, but it would be good for you to see it at least
exactly
functional, so you can say, okay, I actually saw the thing run, so it's not like a fake gyro, because with Trump around, everything's fake news, right?
I wouldn't suspect that. I kind of, what my philosophy in life is, to trust to certain points, like this kind of thing. I always trust what people tell me, and the way that is it's they expose themselves a lot quicker, because people that do on other people, they look for weaknesses, and he seems to think that kindness or being happy or that kind of thing's a weakness. So you kind of find the whatever, the idiots tend to reveal themselves a lot quicker, rather than sitting about 2 years while you're defending it. You know what I mean? They can hit you bigger. I'd rather get it over and done with. So I trusted what you're doing. It's all.
Yeah,
I don't do auto fake.
I finally got this apart. I'm just gonna grab a piece of tape to hold up. This is the stupid power flag. And if I don't tape this up before I press it out, it's going to flop down and I'll snap it right off. So 2 seconds.
No problem. Yep. No rush. So what do you think so far, Chris? Good. Quite good.
Yeah. It's just getting better. Yeah.
Yeah, good stuff. Yeah, it was quite interesting. As I say, it's not very often you get an opportunity.
And for those people that are watching, I guess I can go through what I did.
Yeah.
Basically, all I did was I took the faceplate off so that I could get, there's the faceplate, with the little airplane. I took that off because this casing on it, on this particular model, slides to the front. I thought it would slide back like every other gyro, but of course not. The one I got had to be difficult.
It's battling against the gods are battling against you.
Yeah. The only thing I would point out there was to people is that the simulator wing of the aircraft is actually etched to the front glass because it's fixed to the body of the of the housing. Yeah.
Yeah.
Yeah, it's actually a little mechanism here. I'll try to show it. So this is the front view, if I can get it in the frame.
Yeah.
And if I turn the knob, it moves up and down because it's got like a little, trying to do this with gaskets and stuff in the way. There's a little rotary arm there.
Yeah.
You can see moving it up and down.
Nice.
And like I said, that's just there as a parallax adjustment. Yeah, this poor thing, when I'm done with it, it's going to need like I'm going to have to sit down and rebuild it and recalibrate it.
Can I? I've got a question for you. Did you ever think in your life you would be broadcasting live on YouTube, stripping down an attitude indicator for 2 flat earthers?
Yeah, no, not at all.
Think about that one.
You go to work on Monday. What did you do at the weekend?
Nothing much. Right. Just strip down an attitude indicator for 2 flat earthers.
We have success.
Yeah, lovely job, my friend. Lovely.
Yeah.
Here we
See,
go.
I actually am a technician because it only took me like
I totally believed you in the first place. I'm no doubt about
it. And I only needed just the one screwdriver, which was fantastic. So, so kudos to the engineer.
Yeah.
So let's see if I can figure out a way to, there we go, show this right here.
Yeah, there we go.
So this is the bottom of the rotor housing. So normally in flight, I think you can kind of see the front here.
Yep.
This will be oriented in this attitude with these arms horizontal, basically. And then if you roll this up to the bottom, you can see the actual pendulous vanes here, which is these two.
Cross. Yeah, them two there. Oh, this is brilliant. Yeah, cool, man.
So it's got 2 little stop screws to keep them from going too far, because otherwise it would try to swing like that model that I made, and they'd go way up here and get stuck.
Yeah.
And then there on the side, if I can get this in the right spot, that blocking all the light. Yeah, let's do this. There we go. Yeah. You know, it might help is if I turn on some light here. Let's do this. There we go.
Oh, there we are.
Now we got some light.
Now we're talking.
So right here, you can see the airport for the pendulous vanes. See how if I turn this way, it's weird because my view on Hangouts is backwards, so it keeps confusing me.
Yeah. Oh, I see. Oh, yeah. Yes.
Right. So normally when it's like perfectly level and everything, this will be mostly blocked like that, right? It'll actually be something like this where it'll allow a little bit of airflow out, I think, on this model, just judging by the way the vane's designed.
Yeah.
But it will release the same amount
on the other side,
both of them. Yeah, see, it's got it on the other side too. And so
nice.
When it's obscuring the hole, it's kind of like the trying to move a sailing ship by having a fan that's attached to the sailing ship blowing the sail.
Yep.
So the net force on it ends up being 0. And then when the vane moves, then you've got 2 little air jets that are trying to rotate this. And if you notice, this one would be pointing up and this one would be pointing down.
Got you. Yes.
And so it'll just kind of spin it into, spin it along that axis and impart a force on the whole system. And then there's 2 sets of them. There's one for basically roll and one for pitch.
For pitch, yeah.
And I was kind of curious because when I was playing around with this yesterday, I was trying to figure out why I couldn't get it to really self-level, because I was like, okay, this one just came back in for an overhaul and it'd been lying on the shelf for a while, so it actually needs some TLC before it would be usable. But it looked to me like the bearings were more the problem than anything, because it was trying to like precess back to level, but the bearings are really sticky, and you can see, like, if I tilt this up, it should just fall back. And
right. Yeah.
the bearings are so shot in this one that it's just kind of stuck at whatever attitude you put it at.
Yeah, it's some bit of machine work. It's quite a good. It's impressive, the amount of bits that are, the amount of parts that are on it. That's taken a bit of thought, to come up with that system. So it's very impressive.
Yeah, because there's 2 big bearings. There's one here, and there's another one back in the housing. I'm going to scooch this a little bit so we can see a little bit more of it. There we go. So there's one big bearing here, and there's another one that's like back here, I bet, somewhere, that's hidden behind all of this electronics junk. And that's what gives you your roll kind of stability there.
Yeah.
And yeah, I can feel this bearing feels like sandpaper in there, so it's probably thrown a ball or 2. And then there's a bearing inside here, just behind this brush block and slip ring assembly, and there's one on each side, and that's what allows that to tilt. So this is your pitch gimbal.
Oh yeah.
This is your roll gimbal.
Ah, nice. Yep, right. I've got you.
And once you understand that terminology, it makes it a little bit easier to explain.
Yeah, I understood what the gimbal was, but now I can actually see it. It's not different from what I thought it was, but it's good to actually see the system. I had a different thought of gimbal, but now I can see I can see it. It's the same concept, it does the same thing, but now I can actually see the machine inside. Yeah. Okay.
Yeah.
Excellent.
And the way, so obviously the roll gimbal, when this thing rotates, it rotates this whole card in the front.
Yep.
So that's what gives you your roll indication, is literally this whole gimbal rotating. And that's actually the aircraft rotating around the gimbal.
Yep.
Mm-hmm.
And then your pitch, if I can, I'm going to cut this off because it's annoying. But
yeah, we'll finish with the spin up. You no need to make sure it's unplugged.
So this arm right here is what's connected to the pitch card in the front. So you can see,
yep,
as I move the gimbal, it moves that pitch card. And there's actually just a little mechanical linkage right there with a little cam, and that linkage just kind of rides in that cam, and it moves that card arm up and down based off which way it pitches.
Yep, right, cool.
And then this bit here is for caging. So when you pull on the caging mechanism, which is over here, I had this thing at 90 degrees out of whack this whole time.
Yeah.
This is the mechanism that actually cages the gimbal and allows you to straighten it out if it's in an upset condition
right.
or something like
Resets.
that.
Yep, right, I've got you. Oh, nice.
And the angle that you set this little metal half moon at, that's how you set the panel tilt for the gyro.
Mm-hmm.
So you would actually get this level, and then you would move this card. You'd rotate this card around with it caged, and that kind of rough sets your panel tilt,
right,
and then you
yeah.
fine tune it from there.
Yep, right. I get you.
And then everything, when you get done, you cover with Gliptol or 2-part epoxy to kind of keep the screws from moving in flight and changing any of the parameters.
Yep.
And the one thing I wanted to show, we were talking about how there's a couple different things that help the gyroscope sort of correct for any errors it accumulates. And the first thing is if I was putting this back together, the first thing that I would change or first thing I would set up is when I put this rotor inside the housing,
Yep.
I can actually control its vertical position within the housing, and that will change the center of balance for the housing top to bottom. Because if I put it towards the bottom, it'll be a little bit more bottom heavy.
Right, I've got you.
And so that's usually the first thing is we get this where it's just a little bit below neutrally balanced on where the gyro sits on its own. And we'll actually put it in here with just the bearings, nothing else interfering with it, and we'll balance it that way.
Right.
And there's actually a screw in that hole right here in between the veins where you can actually do that. So I would set that, and now that thing is slightly bottom heavy just in the rotor housing. And then we put it in the roll gimbal, and I would do the same thing in 2 different axes with balancing the roll gimbal. So if I tilt this over, you'll notice there's a screw right there.
Okay, yep. See, yep.
So that screw is, I think there's one on the other side as well, usually. Maybe not on this one. But that screw is for balancing the roll gimbal left to right so that the thing stays sort of neutrally balanced this way.
Got you.
And then the roll gimbal itself has this great big block of weight here. There's actually a nut and a lead weight. That's what this gray bit is here. That is making the roll gimbal slightly bottom heavy as well.
Yeah, I get you. So it corrects itself with, yeah. So it actually wants to go to the bottom, so it corrects
right.
Yeah, it has a bit of inertia on it. So yeah, I get.
Yeah, it's actually that's actually a good description. Is it's kind of dampening the motion out because it's got a little bit more inertia than what it would have without that, and plus it's also a little bit bottom heavy. So if you rolled, did a complete barrel roll, it has something to help fight against the aircraft, other than just the gyro.
Yeah. Just to hit. Yeah, I've got you. Yeah.
And so that's the first thing is you get the balance on this thing set so that it's just slightly more bottom heavy than neutrally balanced. And that will help your gyro sort of correct for any error it's got built into it.
Any flaws in the machining or anything like that, it's
because this one here I think is actually, now it's a machined one. I can tell by the surface of it, but some of them are cast, and there's just such a variability in it. So let's see. So that's the main balance part of it. Now, the pendulous vanes part. So you could get the gyroscope to basically self-correct with nothing more than just having it slightly bottom heavy. But the problem is it takes a lot of time for it to straighten itself out with just that system alone. Like it might take it a half an hour to drift back over from a 10-degree error.
Without the pendulous vanes.
Without the pendulous vanes. If it was just the bottom heavy nature of it, it would take a really long time.
Right, cool. Yeah.
In fact, when we balance these, we tape the pendulous vanes together like I had in that picture so that they don't flop around and throw the balance off.
Yeah, right. So they're actually in position they would be when it was vertical kind of thing. You tape them together kind of stuff and then balance afterwards. Right, cool. Yeah.
Yep. Yeah, so with just the weight system alone, it would take forever, and they needed another way of speeding that process up that would also be just as accurate as the weights alone. And so what they've done is they've got a system of involving these two pendulous vanes here and air being blown out from the bottom of the rotor. And the operation of the vanes is pretty simple. I mean, it's literally just a little pendulum. And so if I tilt this rotor, you can see that the vane tries to stay level while I tilt the rotor, and eventually obscures the hole. Just like that. So literally the only thing that's operating on this vane, either when it's running or when it's just sitting on the bench like this, is its natural tendency to want to stay level. And so as the gyro picks up a little bit of an error, then this vane is going to open up slightly. Like say the gyro wants to be here, right? And say it picks up an error so that it's like this. Well, now that vane is blowing air out, and it's imparting a force on this, and it's going to drive it back until it obscures that hole again.
Yeah.
And here's where the story gets weird. Because this is the thing that took me honestly 3 months to get my head around when I was a brand new gyro tech and literally just kicked my butt. So I would have a gyro that always said wanted to roll. I'm just going to throw it around to the front here. Yeah. So say this gyro, I would get it caged nice and level, and it would always go this way, right?
Yeah.
And so I would adjust my weight right here on the roll gimbal because I thought, oh, it must be off in roll, right? So I would throw some more weight to the right because it was going left. And then I would recage it in a level condition, and this is what I would see. It would go up. I'd be like, what the hell? Now my pitch gimbal's off. And so I would adjust the weights on the pitch gimbal, and then it would go like this. And it was getting worse and worse.
Okay.
And I'm like, what the hell am I doing wrong? And when the guy that was our head gyro guy was like, you have to remember that it's kind of the left, in this case, the left-hand rule. There we go. There we go. The left-hand rule. So any force that you apply to the gyro goes off by the way your fingers are in your hand. So if you push on your thumb, it's going to make it want to go up.
Yep.
Yeah.
And that was what I found was if I wanted to correct it in pitch, I corrected that by adjusting the roll balance screw. And if I wanted to correct the roll, I corrected that by adjusting the balance on the pitch gimbal.
Yeah, it's I think you mentioned it's counterintuitive
Yeah.
It's quite a strange thing, the gyro, but it's totally counterintuitive with the opposite force kind of thing, or the 90-degree. According to which way it spins as well.
Yeah.
It's important which way it spins,
So as you were putting the imbalance into it, the pendulous vanes would open in the correct way, which would make it go the opposite. Yeah.
Right. Yeah. So the pendulous vanes, they only have one mode of operation. And so if the balance is off, then it's trying to drift, like say to the left and up, and the vanes are trying to correct for that. But if it's too far out of balance, then the vanes can't overcome that torque that's being added by it being out of balance. And it sort of reaches an equilibrium point where all of a sudden, the thing is cocked over to the side and pitched up slightly. And you're like, what the hell? And, your first question that you had was actually a really smart one, because that's a detail that a lot of people don't notice. But, normally when it's sitting, like the aircraft's off and you go to get in it, it's going to look something like that, right? It's going to be cocked over to one side, and it's going to be probably pitched up or pitched down.
Yeah.
Then as you fire it up, it'll level itself back out. And everyone's like, well, why does it always look like this when I get in? And it's because you're overcoming the torque created by the gyroscope as well. So you have to kind of balance the torque out by having the thing balanced in the opposite directions. Otherwise, that constant moment of torque that the motor's providing would just cause this thing to tumble.
Yeah, I've got you.
It's the same reason that a helicopter has to have a tail rotor.
Has to have a what? Sorry, I missed that.
Oh, it's the same reason that a helicopter has to have a tail rotor to keep it from spinning.
Yeah, right.
So in a sense, our unit being slightly out of balance is acting as the tail rotor for the gyroscopic motor spinning up. And that's kind of how we correct that part of it.
Yeah. Brilliant.
So yeah, there's a lot that there was a lot more to it than what Fight the Flat Earth was explaining. I think.
Yeah, well, and also me as well. I was, I could explain most of it, but the pendulous vanes, because I hadn't, I couldn't get a picture. I read so many manuals, and it was just exactly what you said. And I watched them videos from Jeff Quinty or the RAF, but there was, it was when you made that video about it and you actually explained it and pointed it out, then it just clicked on me, and now, it's given me a deeper understanding. But now with your demonstration there, it's a great job. If there's more you want to talk about them, you can go all nerdy if you want, or if you've any sort of strange facts about whatever, I'll be interested to hear. Or if Chris has got anything to say, or unless you've got something more to talk about FBL, if there's anything more you have to say.
Yeah. Does Chris have any questions? And then we'll.
No, you can pretty much understand why they went to electronic systems. With all the mechanical wear and all the variants in these, and it was my understanding as well from the some of the documents I read that if you get these aerobatics, or the what do you call them, the display teams, they will cage their gyros as they're performing their routines to save any mechanical damage in some of the quick maneuvers they're doing. So I guess too much knocking about will wear things out, and it's no wonder they turn to the electronic systems.
Yeah, I mean, these type of devices are really designed for your average general aviation type aircraft. So something that never exceeds like 30 degrees of bank, and doesn't do aerobatics and that kind of stuff. Because I mean, it is pretty hard on them if you flip them around constantly and stuff like that. And you can actually get there's a little plastic clip that comes with a lot of these where you can pull the cage out and put that clip in there, and it will permanently keep this caged.
Yeah.
And yeah, if you're doing aerobatics, you're not really looking at your gyroscope anyway.
No.
That's for sure. Yeah. Not a very good time to be looking at it anyway.
But the only thing I would say for anybody that's watching, or now or in the future, is basically that the gyroscope itself, the actual spinning rotor, the whole aim of that is irrespective of the gimbal and everything. The whole aim of that with the pendulous vanes, is my understanding, is that has to stay pretty much vertical all the time, and then it's the cage which is basically fixed the aircraft, which is moving, but the pendulous vanes will maintain that gyro in the upright position, so long as the inertia on the gyroscope isn't excessive. So obviously if you bank the aircraft too much or you roll it, it's going to just spin and tumble until it finds itself. But in normal flight, when you're actually pitching the aircraft, or you're actually turning the aircraft, the gyro inside the spinning rotor that you showed will pretty much maintain its vertical position. Yeah, that's why it's bottom heavy.
Yeah, I mean it is pretty good at maintaining its position on its own, so that as you turn the aircraft around, it gives you a pretty accurate reading of what your orientation is.
Yeah.
It's not incredibly accurate. It's accurate to like maybe 5 degrees or so.
Yeah.
It's good enough to get you into a standard rate turn, but that's about all the precision you need in an aircraft, really. So.
Yeah, I mean, it's not as if you're flying 5 feet above the ground, is it? Which would be, you know.
Well, and the one myth that I really wanted to spell about this, because there's some guys that seem to think that like once you spin up a gyroscope, it's perfectly rigid in space. And if I spin this up and I put like 1/10 of a gram weight on the roll gimbal, it's going to start to slowly pitch up. It's literally that close of a precision balance in order to keep the thing working properly. That's why they have sealed housings, and you try to keep the moisture out of them. They've got big dust gaskets and stuff on them because fine changes to the balance can throw the thing off. And so, given the fact that a gyroscope will precess pretty easily, you have to have a system that's independent of the gyroscope to kind of precess it back to level. And that's the point of the pendulous vanes and the having everything slightly bottom heavy.
Yeah.
Yeah, well, I have to admit, it's an amazing piece of engineering anyway, that for somebody to come up with that, and all the things that they had to think about, all the everything that they had to think about. So.
Yeah, I mean, even something as simple as this is the power flag. So if normally in flight it's kind of up and away, and this thing is usually painted bright orange, but if you were to lose power to this gyroscope, it would pop down like that, and it would tell you, don't trust this instrument because the gyro is not running properly.
Nice.
This one's all bound up.
It's just little things like that, they've thought of everything.
Yeah, they're pretty cool little machines. They're kind of fun to play with. And yeah, like I said, I really saw kind of a fun opportunity because I did do a search kind of digging around YouTube, and I found a few videos that were kind of close to giving a good explanation. But the thing that amazed me was the pilot videos. Like you go on AOPA and you look at how they explain gyros, and it's like, whoa, you guys are missing a couple of things here.
Yeah. I mean, those guys only got to read them, right? Not to know how they work, right?
Yeah, it may be one of those things that you don't want to over bombard them with knowledge that they don't really need. So you just explain to them that it works.
The basics.
Trust it. And
yeah,
just drive the school bus,
Yeah. I mean, let's face it, to drive a car, you don't need to know how an engine works, do you? Just know that if it's running or not. Yeah. The basic temperature, fuel, um, and oil pressure, I guess. That's all you need to know.
Of course, this is. I mean, this. I know it's a bit nerdy, but I find this stuff fascinating. No matter what, it's another piece of knowledge, and it's nothing to do with any ulterior motive or whatever. I've always been into. Yeah, I just like picking up, different bits of knowledge. So I'm very impressed with the instrument. Actually, the more now that it's been described, I just think of all the engineering and all the work, all the measurements, and I know it, as you say, it's not precise, but I just think all the parts to it, and how the person that first came up with the idea for the gyroscope, where it was developed. It's an invention, that's all,
Yeah.
Quite impressive, and it's overlooked as well, and I would only stumbled across this if I hadn't, got into what I got into the flat earth. So stuff like this fascinates me. So,
well, and I did get a really good question from somebody when I was discussing this at work, and I guarantee there's somebody else that's out there watching this now that's probably got the same question, so I may as well answer it for them. Because I was explaining that, this doesn't have to be super accurate, and it can take, it can be 10 degrees off and take 10 minutes to get back to level, because that's what the testing standard is. And they're like, well, that seems like it's not really super accurate for safe flight. And I said, yeah, I mean, if that was the only thing you were looking at, that would not be the most safe thing. But you got to remember that, below this, you've got a directional gyro that's telling you how much you're turning left to right. And because of how an aircraft works, if you're cocked over, at 10 degrees, you're going to turn in that direction. And you would see your directional gyro starting to indicate that you're in a turn. So you're constantly kind of cross-checking all of your instruments against each other, because you've got you've got your attitude indicator, you've got your altimeter. Your altimeter will tell you if you're pitched up or down, if you're ascending or climbing.
Yeah. You've got your heading as well, haven't you? Your heading will change.
Your directional gyro will tell you your heading's changing. And then you've also got a turn coordinator or a slip indicator that's going to tell you that your plane is in a turn. And all of those instruments kind of agree with each other to a certain extent, but any one of those instruments by itself can be slightly off, and it doesn't really matter because you're constantly checking between all of them. And the real value of an attitude indicator is if you get yourself into what they call IMC, instrument meteorological conditions, where you're basically stuck in a cloud and you can't see anything. In that case, it's very easy for your inner ear to get fooled, and you have to learn to trust that this thing is at least telling you which side is the ground.
Yeah.
Because a lot of pilots have died because they thought, no, I'm right side up, but they couldn't see the ground, and so they pulled the wrong direction on the yoke, and next thing you know, well, there's a mountain, and oh shit, I'm dead.
Yeah, so it is handy, it's like, it does, even though it's not accurate, as you quite rightly mentioned, when most of the time you're flying, you're looking out the window, you're checking your instruments, but only at certain points, as you quite rightly pointed out, you've got a lot to do with vision until you really get into what you said, fog or low cloud or high cloud or whatever, so.
Yeah, I mean, honestly, the only time I can remember like getting tunnel vision looking at my attitude indicator is when you're doing like your really precise steep turns and stuff in school, and the instructor's like, okay, I want you to do a 30-degree steep turn, and you've got this thing like you're trying to hold it dead on because he's looking at that dial. And of course,
Yeah,
the point of that
that-
exercise is not for you to be able to hold it to this dial, but to be able to look out the airplane, recognize that you're at about 30 degrees, and cross-checking your instruments to confirm it. But
yeah.
Yeah, cool. So, yeah, I'm glad you guys enjoyed that.
Yeah,
Oh,
very
yeah.
much. Thank you. Yes.
Yeah, and it's brilliant. If there's no, I don't have any questions at all. You've basically just done. I think it's a great demonstration. You went really precise into it, and I'm more than happy, more than grateful. You took the time out of your busy life at the weekend to come out and teach, and I do,
Well, cool. I'm glad you enjoyed it. Now, I'm glad you guys got something out of it. And I think this will be a great resource for when you get people that say, no, a gyro works like this. You can go back to this and say, no, here's a guy explaining and showing how one works, and email him if you've got more questions.
Yeah, exactly.
You might get inundated.
If you want to, if you want to sort of cut out the bits, taking this, because I'll just leave it up. If you actually want to cut it out and just cut out the questions and just put sort of slice it together as a video, how you took it to pieces and stuff like that, or you want to redub over the top of it, put a commentary in and explain it. You're more than welcome to do that.
Actually,
put it up on your channel, and because I think it was great. I really enjoyed it, and
actually, if you wouldn't mind, I might just mirror it straight the way it is on my channel, and then we'll just have something to reference. I'm not a big fan of editing stuff, because you know how hinky that gets with people.
Yeah, I've done it myself. For a 3-minute video, I was using the OpenShot. I use Linux, and I was using OpenShot video editor, and the computer I had, it couldn't quite handle it. So I was getting I had 20 clips, and I got it all together, and it kept crashing on me. And then I had to. It would only remember a certain batch. So for a 3-minute video, it was taking. I've been a day and a half getting the sound right on it and stuff like that. And so it's, as you say, when you said the videos that you made a year ago took you a couple of weeks or a week, they were very well done though, I have to admit. Did you do all the work yourself on the videos, the actual videos, the images? And stuff like that?
I mean, I do all of that stuff.
Yeah.
So I've got the standard freeware audio. Was it Audacity? And
Yep.
And I had this terrible potato mic. And the fact it's sitting here.
All right.
This thing is designed to clip onto a laptop, and I thought, well, it seemed like it was a pretty good idea at the time, but the audio quality on it was just kind of terrible, and I ended up having to do 4 or 5 hours of just audio cleanup.
Right.
And so I released that second video, the one where I did the gyroscope thing using that microphone, and I still had to spend 2 hours balancing the audio or something like that. It wasn't maybe that long. It was maybe 45 minutes, but still, it was 45 minutes just to tweak it.
Yeah, it takes time though. I've been there, so. Well,
and then I got this new microphone that I've got, and it took me, the last episode that I did, I put up 2 versions initially just so I could see the difference in the audio quality. And it's literally, I click on 3 effects that I have saved, and then I cut, and make any content edits, and it's done.
Yeah, right.
And I was like, okay, well, that's definitely worth the money then, to cut out the 3 hours of fighting with audio stuff. So, and I finally got myself a pop filter for it, so now I can say Peter Piper picked a peck of pickled peppers without it sounding like.
We're going. Yeah,
that was
get
driving me
feedback.
nuts.
But I have to say this, right, and I was going to do it in the. I hate that emailing back and forward. That's why I prefer chatting one-to-one
Yeah.
kind of thing. You know, myself, that email. I'm 52. I can't be bothered with the typing. But anyway, yeah. But the point was, the videos. Now I have to say, the videos that you do, they were better. And you know, I'm not blowing smoke or anything like that. I enjoyed them videos, even though I know you've got your certain, I'm going to say, misconceptions of the reality we live in. But the fact was, they were like way better than that Vsauce. If you could, because I was thinking, because if you could get that, because I think you should, I think you've got a lot of topics that you could actually talk about, you know, like certain subjects and do it in the, because you've the interesting short videos, the way that you put it across, and I think you could be quite successful, and not just making it off what a lot of people are doing, making money off the flat Earth. I just mean, you know, there's probably stuff or things that you hear people saying that's totally wrong, and then you could think, right, okay, I'll do a video on that and about that. But big misconceptions, you know, about certain things, like that, it was just an idea, rather, that I thought. And
Oh yeah. I'm definitely not going to just be like, you know, picking on flat Earth stuff exclusively.
oh no, I didn't mean it that way. I didn't mean it that way. That was just a flung in there. It doesn't bother me, but I think you've got a very good way of. It doesn't sound as if, because when that Vsauce, I just watched a couple of his, as every flat earther has. He watched a couple of his, and it was as if he was talking to children, right? But you were doing it in a way that doesn't make the, you know, he didn't make me feel like a child, because I was looking at his presentation, because I know it's about presentation. I thought, it looks like he's talking to children, and there's grown men or grown people going across there, and you know, Vsauce and that. So I thought, you know, the way that you put it across, I thought it wasn't like, there was a nice bit of humour there, a bit of dry humour flung in there, but it was.
It's almost as if you could have been teaching your students, you know.
Yeah, exactly. That's it. Yeah, a more mature way of putting information across, even technical things, and you could even have, you know, people question of the week or whatever, and do a short video. You know, once you've got it off pat, I suppose. But that was just an idea I had. But you know, I would encourage you, you know what I mean, to actually do that, because they were really, I was really impressed, you know, when I seen them. So, but just saying, you know.
Yeah, and I'll give you kind of a teaser. Just because I've already got it written out, I think my next episode is going to be on density and buoyancy, combined with why planes don't have to dip their nose.
Right.
And then the next one after that I've got is kind of a breakdown of like anti-vaccine stuff, and like at least getting rid of some of the internet myths and stuff around vaccines and health, and kind of tackling that subject. And then I must have like 30 or 40 different things in there, including I kind of want to explain a little bit about orbital mechanics and like how spacecraft work, kind of stuff, because that's what my background kind of is in a way, because my dad actually worked on he was literally a rocket scientist. So
All right, cool. Well, you better not let the flat earthers go. They'll say he's a paid shill from NASA. Honestly, mate, I wanted to.
I wish I could get NASA money.
Do you know what you're getting yourself in for? But I can assure you that no, you know, I'll yeah. There's, you know, it's a crazy thing, and I think that you'd fit in good with you know. As I said, I wanted to do something on the non sequitur just to introduce, because I do like the way that you put things across, and I think, you know, you're giving information to you're educating the two sides, and I know that you know, it's about critical thinking, and you know how you know, solve problems, or you know, how you digest knowledge that you've been given and stuff like that. So I kind of like that kind of stuff as well, you know.
Yeah, and I want to do like some fad diet stuff, and like the one group that I really want to go after the hardest is probably not one that you would guess right off the top of your head.
No, go on. Go on. Or Chris, you might take a hit.
No. The one group that I really want to go after the most is the way like science and stuff is reported in the mass media.
Oh yes, please. Yeah, I like that. Yeah.
They are the biggest source of misconceptions that people have, like far more than any of the internet communities and stuff like that.
Yeah. I'll agree there, mate.
The Katie Courics of the world have done more damage than anybody. So I really want to kind of hold their feet to the fire on some of it.
Yeah, we tend to do that ourselves, don't we, Ali?
Yeah, we do. Yeah, we do kind of. You know, as I say, what I was kind of talking about there was the quality of information, because I got most of my information from the media, documentaries that I got, because that's why I find these fascinating, because I'm a bit of a geek when it comes to technology and way things are built and understanding things. You know, I've got that maybe perhaps a childlike quality, but when I actually got into the science side of things, I thought, wait a minute, you know, the quality, or you know, I've got maybe more questions when I looked for the answers, like what you were talking about gyros there, and you found it strange, pendulous veins. Not that anybody should make up a video, you know, of that, but I'm just saying when that kind of information, and when I was looking at the information and listening to like the actual forget about Brian Cox and DeGrasse Tyson, because they're part of the problem, because they are more media than anything else kind of thing. I think they've kind of sold their scientific soul to the devil kind of thing and crossed that boundary, because they're still, you know, they're well, yeah, something annoys me about them, about the way they put things across, and that, and they definitely put it across from a bias position, but I don't want to bring that subject up at the moment. But the point is, that was where I was getting my information, and then suddenly I go, let's have a look, and understanding what an electron is and what do you call it, a particle is. Well, I've got the pictures already in my head, so when I do read a paper, you know, a peer-reviewed paper on a subject, I do understand, because I've already got the understanding, not the mathematics, but the explanation of what this electron is doing, and you know what state it's in, you know, energy state, you know, how much energy it's holding, or you know what actual state it is, and stuff like that. So I've got them pictures. So when I'm getting the explanation, I've already got this in my head, the pictures, and they're not matching up. So I think that's a great subject. It's like a very good subject you pointed out there. A good picture.
Oh yeah, because that's one of the ones that's on my list.
Good stuff.
Quantum observer effect is something that just confuses the hell out of people, and when you hear somebody like that's at the smartness level of someone like Steve on Non Sequitur's show, they tend to like go back into that scientific legalese I was talking about.
Yep, and instead of explaining it, look, if you know that language, you should be able to say it in a simple terms. You know what I mean? You'd be able to give a description, because it's something that you can relate to an observation. You know, if you're, you know, it's good to say, well, think of an atom as a ball, and then you can work with that picture, and then people understand it quite simply. But when it comes to, you know, he does the odd dirty trick. He done it with me there. It's like, but I don't mind. I've known Steve for years, and I was trying to keep on subject, but about when they bring up superpositions or they fling in oh, do you know this equation? I'm like, well, I don't need to know it. They've explained. I know what their values are, and I know I don't really matter. It's what that equation is describing, and what it's describing. It doesn't matter the maths, but what it's describing. It just sometimes the evidence is a lot of supposition and stuff like that. But that's with what I've been taught by the mainstream media kind of thing,
Well, and that's kind of why I decided to do YouTube instead of a podcast, which was another option I considered, because I struggle to explain things with words a lot of times, but I can draw you a picture and explain it better that way. And or I can come up with an illustration using something like SolidWorks, and I'm doing that in my shop all the time. The QCs that work under me, because I manage one of my jobs of many jobs is managing quality control. And, they'll come over and ask me something, and my explanation would involve me spending like 5 minutes in front of a whiteboard. So. But they get it. They understand it by the end of it, and then they're able to apply that knowledge, and they're like, okay, well, so I'm going to stick with the whiteboard thing because that seems to be working.
Yeah, Chris has got one, if you noticed in the background. Chris has got one. He does, when he's telling me about, all the electronics and stuff like that, he'll draw out the drawings and say, right, the current moves this way, the magnetic fields going this way kind of thing. So he's another fascinating...
Pictures is worth 1,000 words, isn't it, really?
Yeah.
Oh, really?
Yeah.
Yeah, I guarantee there's no way you could explain, base to emitter operation in a transistor without drawing the diagram. I can't see how you could explain that just with words.
Yeah, very true.
Yeah. So it's all about, and that's what I think. I think that's what people, because I think we're living in a society where we've been given all the pictures instead of, I like to read, and I think when you read, that character that you're reading, it's you've made him up. That you've got because personally myself, when I read a book, you imagine what that character is, what they look like, and then you build all the characters, and these are, you imagine what they are, what size they are, kind of thing, and then you're building this up, and it's a kind of brain exercise. But when we're living in a world that we're bombarded with pictures and stuff like that, to the point that the only way we can really understand it is through pictures, because that's how our brains are kind of wired now, actually. So it's easier to show and get your point across if you can go, look at this, just draw it for people and give examples of what you've done there.
Well, cool. Then I'm glad this was not wasted.
Oh, absolutely.
Everything actually worked out, so I'm pretty tickled with this.
Yeah. Well, I'm going to. Well, do you want to say anything in closing? And I'll stop it. I'll stop it now. And
Yeah.
Can I? I'll stick the link. If you just Google fact-based living on YouTube and just go to FPL's channel.
Yeah, and I'm going to try to do an episode a week, depending
nice.
on my production schedule. It may be an episode a week, it may be an episode every 2 weeks, but I can't imagine now with the setup I've got it being more than once every 2 weeks. So
yeah.
And if there's something anybody wants to see me illustrate or answer in a visual medium, just email me. It's fact-based living all smushed together at Gmail. And I'll be happy to tackle pretty much any subject and see what I can come up with.
Yeah, I thought you could actually, when you were talking about, because you were talking about critical thinking, gyros, and the way that you were describing, I thought, this is it's definitely be worth asking you, just what you said there. Oh, do you mind doing one on this? And then you give your give your opinion, because they're thought-provoking as well. Because you can still argue with the idea. You know, you don't have to agree with what you're saying, or people maybe take away, oh, right, I didn't know that. And it sends them off in thinking, but it's like what Chris said, it's more like you're talking to students rather than children, which it's a good talent, you know. But yeah, I'd encourage everybody to go across there and you know, email him or just stick a comment in his videos and don't go too hard on him.
That's all right. I can take it. I'm sure I'm going to get at least one, you know, kooky comment a week. So bring it on. Come on.
Yeah.
Yeah, that's it. I bet it'll be good because there's a lot of people in this. You know, as I say, I hope people understand. You know, you'll be fair in your questions. You've done a great presentation. You know, and it was like, you know, what you were doing actually, it was basically you were like teaching and explaining rather than trying to prove a point, and that's how I wanted that. That's how I exactly wanted it to go. You know, and we didn't talk about this or anything like that. I didn't say, oh, make it like a lesson. You just naturally done it, and that was perfect. I couldn't ask for.
Well, and the other thing I want to point out to people on, you know, my side of the aisle is notice that we were all able to have a conversation without like yelling over each other.
Mm-hmm. Yeah, that's what you get with us, I'm afraid. Yeah,
and nobody had to use a ding.
Hey, watch, don't get that copyrighted.
That's actually my bicycle bell. So
all right, okay,
we can have some fun with that.
Yeah, apparently someone got a strike for using their bell. I don't know. I can't remember who it was. It was just a hangout I was watching or something.
Yeah.
Someone did a ding or something, but it was quite funny.
Yeah, somebody did like a weird copyright strike on the guy's channel, and then that brought attention to him. So then apparently somebody had copyrighted the actual ding noise that he was using as a sound effect. And so
and he got it on the uncopyrighted material or something off of YouTube or some sound thing I think they get. I mean, that is, do you know, that's beyond ridiculous to me anyway, you know.
Yeah, and that worries me because like my intro music came from a royalty-free music site, and then when this whole thing came up, I've been trying to track down like exactly the original artist so I can make sure that I'm not really breaching copyright with it. And until I figure that out, I think I'm just going to drop that part of my intro out and maybe use one of the free YouTube ones just to make sure I'm not like stepping on somebody.
Yeah, that's probably a good idea because there's an awful thing at the moment, you know, on both sides. I hate talking about the sides, but there's just like two groups from different opinions, if you want to say. And they've started doing that, like hitting channels with copyright strikes, because apparently you can do it without even owning you can do it on behalf of a company. Apparently, and YouTube will automatically, you know, it's like guilty until proven innocent kind of thing. So, and there's been a bit of spate of that. So I would, you know, warn you just to, do what you just said there until such times as you find out, you know. Unfortunately, it's the arena that we're in at the moment. But things, you know, you still meet really good, you know, no matter like Steve McRae and Kyle, no matter, you know, it's a show after all. I've known Steve for a long time, and you know, it can be offensive to people. I don't mean offensive, but you know, just maybe it's just his way or something, and I'm not. You know, I'm not easily. I've not. You know, I've got a hard, thick skin, like you said. Bring it on. I've got a thick skin, so I let a lot of things go. It's just they just make me giggle. You know, the little sometimes half the time he doesn't even know. He's just saying it because that's how he's thinking. I like the he's just speaking the truth, how he thinks, basically. So if he thinks you're an idiot, he'll tell you that, but in a way, a funny kind of way. You know what I mean? You know, I know you don't understand mathematics, Ali, but you know, and then he'll say, you know, something like that, and not meaning it nasty, just like, yeah, like Sheldon based, just speaking the truth. Sometimes, you know, that kind of thing. And I respect people like that. So, but he can be a bit of a dick. He can be a bit of a dick, but we all can be, you know.
Well, I was kind of, you know, busted your balls a little bit when we were trying to set this up originally. We were kind of going back and forth in the comment section. So I didn't mean it to come. I went back and I read them and I was like, oh man, that sounds like a dick.
Red, when we were talking or what, and when I was commenting, or Chris, are you talking to or what? No, me.
I think it's just down to the meter phrasing with the written word, isn't it? Really, it's the context. It's hard to get it exact unless you're actually speaking to somebody. Well,
that's why I like that. It's less of a misunderstanding kind of thing.
Yeah. And now that I've done this, I've had I never really talked with people online before I started this, and I've had, like, in the past week maybe 10 kind of online conversation interactions, and they're all people that have channels, and most of them, I think all of them, but maybe 2 were people that I disagreed with, you know, fundamentally at some point. We all had good conversations, and I kind of looked at my wife last night. I was like, you know, it's weird. I've had all these positive, you know, interactions with people, but if you just watch YouTube, you would think that everybody's a jerk.
It's like a war out there, man. You know what I mean? But it is, though. You know, I've been in this. FPL, I've been in this arena this is about 5 years. I think this is my 6th year in it, and it's honestly, man, it's been a fascinating subject. I've learnt so much, and you know, and there's people like yourself, and I have to include Christopher, don't come along very often. You know, I appreciate you guys so much. It's my wee, you know. And like people I can talk to, even if we disagree. I disagree with Chris on some things, you know, when we don't, you know, but we can still talk because we're, you know, we like learning or listening or teaching or whatever. So, but yeah, you'll get a lot of. You should get most of the comments, but don't worry, I'll stick up for you. Don't you worry, man. As long as you don't go down the lower down path, you kind of belong maybe in a higher intellectual arena, where, you know, like, as I say, like with Steve McRae or something like that, you know, because I think you'd also get on quite well over there, you know, if you had things to talk about.
I actually contributed.
Well, you have
on non sequitur the other night, which was surprising.
Well, what was that? Was that in the chat?
Yeah. So they had the one guest on that was talking about electric Earth or electric universe.
Yeah, right. I've seen that. I never read the chat though. Yeah, what was that about?
Yeah, and yeah, it was very confusing. I agree. I was trying to listen to it, but I was also working on stuff for my channel, and yeah, none of his narrative really seemed to tie together with anything. But towards the end of it, he had this one picture where he was like, "This is an example of water on Mars flowing uphill." And it was like that's what it looked like. It looked like there was like a river channel with like a hill in the middle of it, and like the river channel clearly went up and over it. And I'm like, that something doesn't look right about this, but I can't put my finger on it. And it's that thing I was saying in my one video about, you know, informing your intuition. So my intuition was telling me there's something not right, but maybe you should research it. And
that was the other one. Yeah, sorry, on you go.
so I just screen capped it. I'm surprised this worked, but I screen capped the image on the non sequitur show, and I cropped it out, and then I put it into an image search, and I found the original image, and it turned out that it was not even a picture of Mars. It was actually a picture of the moon in every attribution that you could find online. So he didn't even have the right supposed solar system body. And also the explanation of it was there was a collapsed lava tube, not like a creek. And I'm like, well, okay, at the very least we can say it wasn't on Mars. So I posted back in the chat, no, here's the original picture if you want to take a look at it. And they asked him about it, and he's like, oh, well, I guess I must have had the wrong thing. And it's like, dude, you just rambled on for like 10 minutes. Like you were absolutely confident about this thing, and it wasn't even the right body.
Yeah, I think what's happened there is because I watched that. He did say that he didn't know much about it. He was like,
yeah,
he didn't admit that, and I thought he was getting a bit of a hard time off the others for it, because I've heard of that electric universe, and even I kind of knew more about it because I did look into it. I even read that Velikovsky's, the Thunderbolts or the Gods or something like that, I think it was called. I read that a few years ago, and in the end up, I didn't really agree with it. I know it's all speculation, really, but I've looked into that electric universe, and some of the stuff that we do talk about, it's feasible. It's feasible. The thing that gets me is these new ideas, they get poo-pooed too quick if they go against the mainstream, right? Do you know that kind of way? And then there's like a campaign, or that's rubbish and that. And I thought the whole point of this critical thinking and taking in information and contemplating it, and then what you done there is you looked into it, you researched it, and there you go, and you thought, right, well that was it. You didn't go looking for, oh, it's fake, because you would have found that it's fake, but you went looking and said there's something not right about that, and then you went and you done that, and so you weren't really going with a preconceived idea kind of thing. You didn't know what it was, but it wasn't right. You know what I mean? So that was like an honest search. I think if you'd found it and it was at Mars, you would have went, oh, right, okay, that's Mars.
Yeah, I mean, honestly,
you understand, sorry.
Oh, no, yeah, honestly, if I had gone and I'd found out that it was Mars, then I would have been trying to figure out how in the hell a creek bed could go uphill, because that is exactly what it looked like.
Yeah. And there's still an explanation out there, but that's what I find funny on the both sides, is that, a lot of flat earth, oh, we are the critical thinkers because we're this. And honestly, I cringe, like you cringed when me and that Fight the Flat Earth was talking about gyroscopes. You're going, like going up there shouting at the computer screen. It's not like that, yeah, idiots. It's like this, okay, or whatever. That kind of, and that's what I see on both sides when it comes to that critical thinking and analysing. I don't have a horse in the race if it's a ball, if it's flat. It's to me, it's like a hobby, a side hobby, an interest kind of thing. It'd be nice to know, but it's not going to control my life, because there's like other subjects. But I do enjoy the conversation, because I do enjoy the science, so kind of thing. So that it's
and I will say that, like what you're saying with people like dismissing stuff too quickly. I think also people have a tendency to accept stuff sometimes too quickly too.
Yes.
And so there has to be kind of a happy medium between the two of them. And I think that's where you and I are. To give an example
sorry for interrupting. I think a lot of people disagree with you on that, mostly on the other side, but I can assure you, but I'll take that as a compliment. Thank you very much. But as I say, I think I can hold beliefs, but understand what their beliefs are based on, and they end up, understand where my beliefs are, and I've chose, well, until such times, that's my beliefs, but I can still, if there's evidence, it comes up and slaps me in the face, I'll go, right, I have to accept this. So I will change my opinion. I have to be, otherwise I'd be lying to myself. And I think you're kind of, well, you pointed out that, and that's where I try to be most times. It's like that, because
you've got to be honest as well, haven't you?
Yeah, well, yourself most importantly, I think.
Yeah.
And it's good. I like the investigation into it. Like, obviously, like yourself, FPL there. I can see that you enjoy looking into things, and with an honest, as biased, as an unbiased eye or mind as possible, kind of thing,
Well, yeah, and I rely on people to, if I start like really sucking up a bias on something and it's pretty obvious, I encourage people to call me out on it, because I'm kind of also the kind of person that when something breaks, I assume it's something I did, because that's the easiest option to eliminate. It's like, okay, start with, did you screw it up? Okay, no, I didn't screw it up. I found the problem. Yay. But it makes it that much easier to accept that you screwed something up if you start with that as the assumption.
Right.
If that makes sense.
But well, it does. I don't agree with that, because I've got a thing about that, about But I totally understand what you mean. Starting there's always a place to start, and right, it wasn't me, so let's look at it this, right, what else is there, kind of thing, I get that.
Usually start off, what was the last thing you did?
Exactly.
Oh, fuck yeah. What did I excuse the language for that.
Yeah. It's like, what's the old adage? Is it doing something it's not supposed to do? That's a short. If it's not doing something it's supposed to do, it's an open. And if it's doing both something it's supposed to do and something it's not supposed to do, then you wired it wrong. Well, cool. So we hit about 2 hours, so I don't want to take up your whole afternoon.
No, well, it's night time. It's 10 o'clock here, but 2 hours is perfect. I mean, that was just, honestly. Well, right. We'll just say cheerio to everybody that came. Thanks to the chat. Thanks to Chris, and thanks to Fact-Based Living. Go across, subscribe to his channel. Just go for that. So we'll just say good night. You want to say anything, Chris? Thanks for listening or whatever.
Yeah, again, thanks for having me on, Ali, and it was great to be here, and thanks to FPL, of course, for taking time out and showing us the gyroscope there, and having the patience to go through it and explain it to us in a way that was most congenial. Thank you very much.
Absolutely, anytime.
Yeah, thanks very much. Do you want to say anything, JBL? Advertise your channel once more before we go.
Yeah, it's Fact-Based Living. That's how you'll find me. My email is factbasedliving@gmail.com. And if you have any questions or want me to do a specific topic, just drop me an email.
There you go. Can't beat that. All right, guys. Good night now, and we'll speak later.